Welcome to Click Academic. This is lesson 4 on the series Mathematical Method. We will be discussing on mean value theorem. Example 2. We are asked to prove that this function satisfies the hypothesis of mean value theorem and also to find the number c that exists between the interval 1, 4. So to prove that this function satisfies the hypothesis of mean value theorem, solution. We know that the function must be continuous on this interval and differentiable on the open interval. So let's see whether the function is continuous or not. To show the function is continuous, we are to find the f of 1 and f of 4, which is our a and b. So f of 1, that is to substitute anywhere we have x in the function, we replace 1. So we have x, and our x is 1 plus 4 divided by x, and remember our x is 1 because it's f of 1. This is equal to 1 plus 4 divided by 1, 4, which is equal to 5. So f of 1 is equal to 5. Then f of b, and our b is 4. F of 4 is equal to, anywhere we have x from the function, we should replace 4. We have x, and our x is 4 plus 4 divided by x, and our x is 4, which is equal to 4 plus 4 divided by 4, 1, which is equal to 5. So the function is continuous on the interval 1, 4 because f of 1 is not divided by 0. The result is not divided by 0. Likewise, f of 4, the result is not divided by 0. Then, to show that the function is differentiable, to show that the function is differentiable on the open interval, let's see. Does the function differentiable? The derivative of the function, we should differentiate the function. That is to find the first derivative of the function. But if you look at the second term in the function is division. So to avoid using quotient rule during differentiation, let's take this x up. That is from denominator to numerator. Then our f of x now will be x plus 4. When taking number or alphabet from denominator to numerator, it will take a negative power. So it should be x raised to the power minus 1. So derivative of the function is f prime of x is equal to derivative of x 1. Then derivative of plus 4x raised to the power minus 1. Remember, differentiation we see just multiply power by the coefficient and reduce 1 from the power. Therefore, minus 1 times 4, minus 1 times plus 4, minus 4. Then our x. Reduce 1 from the power, that is minus 1 minus 1 is equal to minus 2. Yes, the function is differentiable. So since the function is continuous on the interval 1, 4, and the function is differentiable, therefore the function satisfies the hypothesis of mean value theorem. We are asked to find the number c that exists between the open interval 1, 4. As we say, to find that number, we are to use the conclusion of the theorem. And the conclusion of the theorem said f prime of c is equal to f of b minus f of a divided by b minus a. F prime of c. From the beginning to this day, we don't have f prime of c, but we have f prime of x. Since we have f prime of x, we can find f prime of c. So anywhere we have x in f prime of x, we should replace c in there. So therefore, our f prime of c will be anywhere we have x in here, we should replace it with c. So 1 minus 4. So instead of this x, we should replace c. Raised to the power minus 2 is equal to f of b. Remember, the interval is a comma b. So f of b is f of 4. Therefore, f of 4 is equal to 5. Minus f of a. F of a, that is f of 1. So f of 1 is equal to 5. Divided by b. And our b is 4 minus a. A is 1. So 1 minus 4 c raised to the power minus 2 is equal to 5 minus 5, 0. Divided by 4 minus 1, 3. Let's divide this. 1 minus 4 plus c raised to the power minus 2 is equal to 0 divided by 3, 0. We are looking for c, so we can take this term to the other side. 1 is equal to negative 4 across the cross sign become positive 4 c raised to the power minus 2. We are looking for c. So since this c, it has a power of negative 2, we can eliminate the negative. And we can eliminate the negative. If we want to eliminate this negative, we should take it down. from numerator to denominator, just as we did before. When we want to take x from denominator to numerator, it takes negative power. So when we want to eliminate this negative, it will go down from numerator to denominator. So this is equal 1 is equal to 4 divided by c squared. We eliminate the negative. We are looking for c. Now we have one term at the left hand side and one term at the right hand side, so we can cross multiply. This one is the same thing as over 1, then cross multiply. By crossing multiply, 1 times c squared is c squared, then it's equal to 1 times 4, 4. So we are looking for c, not c squared. So we should now take this squared to the other side. So c is equal to, taking squared across a sign becomes square root. And remember, once we have square root, it's either plus or minus. So plus or minus square root of 4. C is equal to plus or minus square root of 4, 2. So that number exists between the interval. We have plus or minus 2. But remember, the interval is 1, 4. Therefore, our C is equal to positive 2, because between 1 and 4, we don't have negative 2. We only have positive 2. Therefore, our C is equal to 2. That's all.